Hi and good day and welcome to DSC1630 virtual classroom. Today we're going to start with chapter 6 and the first section on chapter 6. Now chapter 6 has got to do with capital budgeting. Now what is capital budgeting? Now capital budgeting, sorry, I just want to get that on the board. Oh, there. Capital budgeting is sometimes you want to make an investment into, you want to buy a shop or you want to do any investment. And you want to decide, is it a good investment or will it be a good investment, yes or no? Should I go ahead? Should I invest the money into this company? And so forth. So that's where capital budgeting comes in. Now with capital budgeting, what we do is we look towards two things. Firstly, money what will go into the business in the sense of that you will get like profits, for instance, that we call inflow of money flowing into the company. And that is normally the positive side of the investment. Then secondly, we look at the money flowing out of the business, and that we call an outflow, meaning that what for in the beginning, we would just like look at one outflow, and that we then call a negative outflow or money going out of our company. So if we draw our timeline again, just activate again. If we think of our business, right, there's money going into the business. We call that our positive inflows, right? And then in the beginning, the outflow, meaning that you will invest. That's what you will pay for that specific investment. We call that the negative or the outflow, and the rest is the inflow. Now, there's different ways that we will compare this positive values and this negative values. And the different in them will give us our different type of formulas or pairing methods that we look at. Now, something that is also that we need to know in these type of things is you normally would go and borrow that money to pay for that investment. And that the cost of capital, or our C value, we also indicate it as a C or a K, right, is the rate at which we will borrow our money. And that is then the C or the K value. You will see why I'm mentioning it now. And then later on, we will also have an investment interest rate where we will take our positives and we'll investment or save it in a savings account. But we'll get to that later on. Now, firstly, the ID is the method will normally be specified. So you will be busy with capital budgeting. It will tell you you've got an investment and you want to know, is it a good investment, yes or no? So the method that we will look at as we go along will give you your ID then. The calculator, some of them you will use your financial mode of your calculator, and some of them then you will be using the normal mode. So if we look at an example of a timeline, there it is. Now, the value we enter or we pay for that specific investment, in short, we call it Z, right? So our Z value is this positive going out here, right? And these pluses we can call A, B, C, and so forth. It can be in equal time intervals, or it can skip a year and maybe be the first year, and then only in the third and the fourth year you will have another inflow of money into the company. So very important again is to draw your timeline, just like with all the other previous example. Now the first thing that we're going to look at, or the first method of saying, is this a good investment or not, is the average rate of return. Now, the average rate of return compares the average cash inflows, income inflows, right, to the outflow. So it will take the average of these values and compare it to your negative, right. So the average rate of return is equal to the average of your positives, right, divided by your outflow or your negative. Now, what is an average? Can we remember maybe back from school days, or when you have to work out your average of your test marks? What is the average? You add the sum, right? The sum means add all together of all your positives divided by how many positives there are, and then your negative. Right. How would I interpret if it is a good or a bad? We compare this average return, right? On average, what will my return be? You compare it to your C or your cost of capital. Now, if your average rate of return is bigger than the cost of capital, then it will be a favorable or a good investment. Why? Because your rate of return is bigger than what it will cost you to borrow money and make this investment. So then it's a good one. And unfavorable when your average rate of return is then smaller than your value C. Now again, how would I ID it? ARR, or average rate of return, will be in the question, and your calculator will use normal mode. Now let's look at the first question now. Aziza Naidu invests 10,000 Rand in a herb shop. Her cash flows for the next 5 years are 1,000, 2,000, 4,000, 5,000, and 6,000. Calculate the IRR if the cost of capital C equals 15%. Is this a favorable investment? So the moment we see the cash flows, we must already see that that's got something to do with our chapter 6 on capital budgeting. Right. So we draw our timeline. 10,000 will what she paid for it. So it's the outflow of money, that's the negative, right? Then coming in will be 1,000, 2,000, 4,000, am I correct? Yes, 4,000, 5,000, and the last one is 6,000. Year 1, year 2, year 3, year 4, year 5, and this is now. Right. What do we know that we want to calculate? It's given to us, ARR. Now, what is the ARR? We get the average of all our inflows, which is the 1,000, 2,000, 4,000, 5,000, and 6,000. The average of that divided by the 10,000. So we know at the bottom, we've got our 10,000. How do we calculate the average? We add our 1,000 plus our 2,000 plus our 4,000, 5,000, 6,000. I'm not going to write everything out. Divided by how many? 1, 2, 3, 4, 5 values. Right, and that will give us, if you use your calculator, be careful. First work out the average and then divide it by 10,000 Rand. So we get an average internal rate of return as 0.36. Now what does that mean? We need to change it to percentage, our rate of return, so it's actually 36%. So if we look at this and we use the average rate of return, then we get an average rate of return of 36%. Now, is it favorable or not? We will look at the cost of capital. If I want to do this investment, or in this case, you already done the investment, that 10,000 was borrowed at 15%. Now, our investments give us a rate of 36%, so this 36% is bigger than the 15%. So yes, I'm going to make the investment. It is a favorable investment. Right, now if we think of this example, we've added different values at different time periods, right? And you all know we're not allowed to do it. So with the average rate of return, it's just a basic indication of the investment possibility. Our next example, or our next method, bring into account then the exact amounts, and not only the 1,200, 2,000, 4,000, but we move all those inflows as well as the outflow to the same date. So the time value of money concept is getting, we applying here, and then we do the comparison. Okay, just quickly going through our examples there. There's our timeline, our ARR, and our value of 36%. Now, the next one is the net present value. Again, we're comparing the inflows to the outflows. And as the word says net, we get the net value by saying, what is the difference between the inflows and the outflows, right? So we subtract the two from each other. Now, very important, as I said, with these ones, we just add them together. But we can't do that with the net present value. We take these values and we move them to now. Each one of them, right? Then we add them together and we compare them then with this 10,000 Rand. So net present value is the present value, meaning now, of all the inflows. So we add all the inflows together now, at time period now, and we subtract the outflows. If the present value of all the inflows is bigger than the outflow, then it will be a good investment. Why? Because the inflows are more than the outflows. In the other way around, if the outflow is bigger than all the positive inflows at time period now, it's not a good investment. Right. So that's the net present value. Just something quickly before we look on the presentation. How do I move something back in time? I divide by the interest component. Can you remember? To get a present value, you take your future value and you divide by the interest component. Now the same we do here, and we use compound interest, or in this specific case, if the cost of capital is known to us, we use the cost of capital. So we're moving all these values back in time using the cost of capital, and that's why if you look on the board there, A, our first inflow, is divided by 1 plus C, and C is the cost of capital, and in this instance, we're just taking it back 1 year. B, we're taking back 2 years. C, we're taking back 3 years, and we add them all together minus your Z, and can remember the Z was the original outflow. If we look on a timeline that I've given you there on our presentation, each year is moved back, the blue line, right? That specific value is moved back in time. Then we add all the blue values together and we subtract the Z value from there. Now, as I said, it will be a favorable investment if your net present value is positive, meaning all the inflows, the sum of your inflows minus the outflow is positive. It means your inflows is bigger than your outflows. And the other way around, if it's a negative answer smaller than 0, it means your outflow will be bigger than your inflow. What is the ID word? NPV method will be specified, net present value. Calculator, you can use your financial or your normal mode to calculate that. Right, there's just one thing that I want to mention, and that is these inflows can also be exactly the same size in equal time periods. And if we want to calculate the present value of these ones, you can either use the method of bringing them each to now and then add them, or if they equal in equal intervals, what do we have? We've got an annuity, right? So when we've got equal inflows in equal time period, we can also use our annuity formula, ANI, to calculate the present value of our inflows, as I explained there on the board. So if this A, B, C, D is actually the same size, 3,000, 3,000, 3,000, 3,000, and they are equal time intervals, that present value, instead of using that formula there on top, we can actually just say it's a present value of the ANI formula. And using our ANI financial mode or calculator normal mode to calculate that value and then subtract your Z value. Now let's look at an example. Again, let's look at Aziza again. We're just going back to our original example, but we're calculating the net present value and see if it gives us the same conclusion. I've got 10,000 Rand here, right, and I've got my 1,000. I'm just going to do a 1 there just to make it shorter. My 2,000, my 4,000, my 5,000, and my 6,000. Let's put the zeros in. Just now you're getting confused where we're working with. 2,000 and then the 1,000. And it's in year 1, year 2, year 3, year 4, and year 5. And that is now. So what we want to do, calculate? We want to calculate using our net present value. And the net present value is equal to what? The sum of the present values of our positives, of our inflows, minus our outflow, or the Z value, you can call it. How do we get the present value? We take our and we move it back in time. How many years for 1 year? Right? So it's 1 plus. Our cost of capital is 15%. 1 plus, let's put a bracket around it. Next one, 2,000. We're moving it back from here to there for how many years? 2 years. So it's 1 plus 0.15 to the power of 2 plus 4,000 divided by 1 plus 0.15 to the power of 3. Why? Because we're moving from here to here, 3 years, plus the 5,000. Again, from where to where are we moving it? From 4 years to now, back in time. So it's 4 years years plus the 6,000, we're moving back 6 years. No, not 6 years, 5 years. From here to there, it's 5 years. Right. Now that you can calculate using either your normal financial mode of your calculator using compound interest, get the answer added to the rest of it, right? Or you can calculate them using the normal mode. So remember to use your memory key if you've got many things that you want to add together. So do the calculation, put it into your memory, and just know you will add minus then your 10,000 Rand. Now, if you calculate that, you will get an answer of 853.74 Rand. 853 Rand and 74 cents. Now, that is a positive, meaning that this total of my positive inflows, that present value of my positive inflows is bigger than the 10,000, right? And because it's bigger than the 10,000, it will be a good investment because I'm going to get more in that I'm going to spend, right? And that 8 Rand is then 0. So in this instance, yes, looking at the net present value, it's a good investment. Why is this one better than the average rate of return? Because we're bringing in the time value of money in this specific case. So if we look at our PowerPoint, I've drawn my timeline. I've moved my money back. I've subtracted my 10,000 and I get 853.74, 853.74 cents. Net present value is greater than 0, so I will invest. So in this instance, we subtracted, that's why it's called net present value. We subtracted the present value of the negative, the outflow, from our sum of our inflows. Our third method of comparing our inflows to our outflows is the profitability index. Now, as the word said, index, it's something in relationship to something else or a ratio. So with the profitability index, we compare the present value of the inflows, like we just had, but divided by the initial outflow or our negative. So our profitability index is again the sum of the present values of our positives, our inflows, but divide by our outflow. Now you can think, if this here on top is greater than the negative, the outflow, what is going to happen? This answer is going to be bigger than 1 because the top is bigger than the negative. And then it is a good investment. If the sum of the present value is smaller, then we're going to have an answer that is smaller than 1, then it's not a good investment. Right, so again, it's just like the NPV, but we've got a ratio instead of subtracting it from each other. How do I calculate this? Again, just with your normal mode or your financial mode if you want to get that answer just like we had. This will be the same if we go back. This answer of this whole thing, but now divided 1,000 Rand will give us then the profitability index. Now this profitability index, right, because the formula of our net present value. We can, the sum of your profitability index, if you think of NPV, what is this? It is the sum of your present value, right, minus the Z value or the outflow. Okay, so if we've got, or we know that, we can take that over, and then NPV plus your Z value is the sum of your present value. Right, if we used an NPV. So instead of having that, we can also write the PI as the net present value plus our initial outflow divided by the initial outflow. Right, so there's two formulas for the profitability index, and this one just comes from the formula of your net present value. You can use either one of the two depending on what was given to you. You can use whatever method you want to use. We go back to Aziza again. Same question like we had. We've got the herb shop invested 10,000 and the inflow, but in this instance we need to calculate the PI. Can you see the method is given to you? Right, so we know it's the sum of all the positives we had, the present value of that, divided by the negative. Okay, we've already calculated it in the previous example. It's 10,853 Rand 74 divided by our 10,000, which give you 1,085. You could have used that, or remember in our previous question, we worked out the NPV to be 853,74 plus the outflow of 10,000 divided by 10,000, and it gives you the same answer. So both formulas, you can use whichever one you want, depending, as I said, what is given to you. You can use any one of the two. Lastly, because it is greater than 1, it means the top part of your fraction is bigger than the bottom half of your fraction, so the present values of the cash inflows is bigger than the outflows, and that will be then a good investment. Okay, so to recap, we had the average rate of return, where we look at the average of all the inflows divided by the outflow, but no time was taken in consideration. Then we look at the net present value. We moved all our inflows to now, add them together and compare it by subtracting our outflow value. The third one, was the profitability index. We again compare the positive now, we're taking our time into consideration, the value now of our inflows towards a ratio towards our outflow, and we compare that, and that is called the profitability index. Now, what is the internal rate of return? Now, the internal rate of return, if we put it in terms, is that rate that if we move our inflows to now and we compare it to the outflow, so it's almost like the net present value, but remember, we moved the net present value, all that present values we moved back in time using the cost of capital. Now, the internal rates say, if I move those values back, the inflows back in time, and I compare it to the outflow, what rate of return or what interest rate must I use to move them back so that I at least break even? Meaning, I don't make a profit, I don't make a loss. What is that interest rate if I compare my inflows to my outflows at the time period now? What will that interest rate be, or then what we call the interest rate, the internal rate of return? So the internal rate of return, it says that will make the present value of all the cash flows equal to the present value of our investment. So we are looking for that value of our I, or our C, if you want to call it, that will at least give us a break-even point, meaning where our outflows and our inflows, if subtracted, is equal to 0. How would we interpret it? That internal rate of return, we will then compare to what the cost of capital is. If the internal rate of return, our rate of return, is bigger than the cost of capital, then yes, it's a good investment, it's a favorable investment. If it's not, it's unfavorable. Now, how would I ID it? It's the internal rate of method is mentioned to you or specified. And then very important, guys, the calculator, you can unfortunately just use your financial mode. You can't use a scientific calculator. It can, but it takes very, very long because you have to guess the value of I, substitute it into the formula, and try and manipulate it till you get an answer of 0 or near to 0. Right. So normally we would use a computer program to solve an equation like that, and you need to use your financial mode to solve that. Right, now let's look at Aziza again. There I've noted that the IRR can't be calculated with the normal mode. It can only be calculated on an iterative way by substituting guessed values into the equation and keep going until the answer is 0 if found, but that takes very long. So you need to use your financial mode, which has already been programmed to give you the RRR. So there we've got Aziza again. We've got our normal timeline that we had previously with our inflows and our now value of 10,000, right? And what is the internal rate of return? It says, at what rate will we get these back? Right. So that this value and this value, if we subtract it, will give us an answer of 0. Or we can say we break even. So we're looking at, if we think of the one plus, we call it I for RRR, for 1 year plus the 2,000, moving it back to 1 plus I square, or 2, and then we had 4,000. Plus the 5,000, 1 plus I to the power of 4, plus the last one. So I need to calculate 5 minus 10, and we call it FI, or the IRR if you want to. I need to determine the I, so that this whole thing will give me an answer of 0. That means then the inflows minus the outflows is equal to 0. The profit minus the cost is equal to 0. That we call break even. Can you remember from maths? Will give you an answer of 0. So we can almost say this is equal to 0. So we need to solve this whole thing for the I to get to the answer of 0. And as I said, it's quite difficult to do it by hand, so you need your IRR mode on your calculator, and if you enter that into your calculator, it gives you the answer of 17.73%. Go back to your booklet on your calculator under additional resources, or go back to your DVD and watch the DVD on how to enter those values to get to an answer of 17.73%. Now, if you look at the internal rate of return of 17.73, what does it mean? It means if you put in there 0.73, substitute it there. Work this out, subtract the 10,000, it will give you an answer of 0. And that we call the internal rate of return. And because that 17,73 is bigger than the cost of capital, which is 15%, we say it's a favorable investment. Here I've just summarized to you the investment decision. When do I accept or reject an investment? Internal rate of return you compare with the cost of capital. We've just done an example of that. The net present value, we compare it to a positive or a negative value, and the profitability index with a value of 1, smaller or bigger than 1, and that gives you an accept or a reject at the end of the day. Sometimes you might find that not all, if you compare all of them, in this example that we had, all of them said positive investment, right? But sometimes you do get that some of them give you a positive, yes, invest, but the others will give you a negative and say, no, don't invest. And then it depends on what you decide, if it's a good investment or not. But normally, if there's one that say, no, we don't do or we don't invest in that specific investment. Right, that concludes in the first part of chapter 6. It's all to do with comparing a lot of inflows to one outflow, right? So in all of these examples, we only had one outflow of money in the beginning. In the next section, we're going to get or look at where we've got more than one outflow of money and then again the inflows of money. And that we call the modified internal rate of return, MIRR, but that will be in section 2 then of chapter 6. So please guys, go back as many examples as you can. You know where to find the additional exercises. Go and practice. Remember, practice makes perfect. See you next time. Bye-bye.